Hello, Calc students. Our Unit 6 is called Applications of Integration. And so what happened today is, well, it's our first day into Applications of Integration. We learned the fundamental theorem of calculus. We have some integration techniques. That was the previous unit. Now we can apply some things. And so the first typical step is to see that integration can find area under a curve, yes, but now if you have two curves, one that might create a boundary on top and another that creates a boundary quote on bottom, you can find the area between curves. And that's how we start this unit. Area between two curves. And so the notes that I'm going to send to you have, thank you Kala, they're just the theory on how to find the area between a curve. There's a little bit, and I'll show you how to use the TI calculator. And then there are other times when things get a little more complicated and we have one function that is below in one area and then above in the other. We just have to split that into two different regions, like R and S, for example. But for right now, I'm going to share with you how to do one by hand, which is just this. Oop. Let's get rid of that. This one. This is called that number one. And so it goes by this. Find the area of the shaded region. We've got two functions there. It is clear that it's x squared plus 1 up on top and y equals x on bottom. And so the region that creates is a shaded region here. And so to find the area of it, we set up an integral. And we need to know the limits of integration here because like where you start is crucial. This time it's clear that it starts at x equals -1 and we integrate up to x equals 2. So those limits are straight. And now we take the upper function, x squared plus 1, minus the lower function, y equals x. And I'll just package that just in parentheses to make it clear that that's upper function minus lower function minus lower. And we're collecting areas. We need to make sure that since it's integration in terms of x or dx. And now that's just a standard integration technique. No u sub, no fancy strategies there. That means I'll do it, an integral from -1 to 2 of x squared plus 1 minus x dx, which gets me x cubed over 3 plus x minus x squared over 2. Those are all the antiderivatives. And then we integrate, or now we evaluate from -1 to 2. It's been a while since we used that integration symbol. And now to evaluate, we get, this is going to be a little fractiony here. I'll start us out, and then I might do a little ... to have you finish the math. That's going to be 8/3 plus 2 minus, let's see, 2 squared over 2 is 2, minus -1 cubed is -1/3 minus 1 minus 1/2. That's going to be, I'm going to ... it for now. Do the math. You should get 9/2 or 4.5. So please make sure you come to terms with those, that fraction there. It's just in a denominator of 6 and you'll get 9/2. So that's one example of how to do it by hand without a graphing tool. Now let's switch over to I'm going to take you back to, this one. Nope, sorry. This one. Oh no, excuse me. Just take this part off. Let's start from scratch here. We have an integral problem, and we've got two functions. This is on the very front page. F of x is a cubic function, and g of x, that's negative 4x. Let's see. First, we need to kind of decide which is f and which is g. F is a cubic, so we want to have something that is a kind of a cubic form. Aha, that is that one in light blue. I'm going to put an f in that first region R to denote that the f is the higher function, and then once it dips down below into region S, f is down below in the second region, and g is below in first, but then it is the higher function after that. So I'm just going to plan out how we're going to do this. Area of R is going to be a sum of, or an integral, that means an area, from -2 to 0 of f of x minus g of x. Now I'm not going to put in the functions right now. We're going to put that into the calculator, dx. That takes care of R. And now the area of S is going to be the integral from 0 to, got ahead of myself. What is that point right there? Don't zoom ahead, but I'm going to show you how to find out with the graphing tool how that is really 1.828. So I'm going to put it in there right now, and we'll get there in a moment. And now that is the integral from, it's the reverse, g of x minus f of x dx. Those two areas are going to give you an approximate an answer for each one. We add them together, and we should get something called, or R plus S is going to be approximately 9.078, I believe. So now I'm going to switch over to another form of education, which is the graphing calculator. So let's see if we can get you zoomed in here. And okay, on your graphing calculator, we turn it on, got to make sure that there's nothing in the stat plot. Those are all off. And then while y equal, I'm going to close you out there, buddy. And let's put f of x, which is x cubed plus x squared minus 6x, x cubed plus x squared minus 6x. That's in y1. I got to remember that. That's y1. F of x is y1. And then below it is g of x. That's negative 4x divided by, and I'm going to put that part in quotes, x plus 3. If I'm lucky and I graph it, it's going to show up really nicely, but I'm not lucky. I need to window my way to see what I need to make this problem work. I'm going to go from, how about from -3? I'm looking back at my picture to see how I can frame this out to about 2. And then my y min is going to be, let's see, that region S is down, I think it's probably around -3, and it goes up as high as 8. I'm going to say 9. Let's see if that frames my picture nicely. And it does. Okay, so now the first thing we're going to do, I'm going to show you how to get that intersection point there. It is not one that you can easily do by substitution or elimination. We should use second calculate. We choose option 5, which is intersect. And the calculator will ask you, which curve do you want? The default will be probably y1. I press enter. You don't have to move your cursor at all. And the second curve, this y2, Don't have to move your cursor at all. Press enter. The third one, you need to say like which intersection point. There's going to be probably 3. There's one up here, one down here. I want that one. So I move my cursor so that it's close enough that the calculator knows that's the neighborhood that I want to evaluate. And we should get, after you press enter, 1.828. That's how its second calc intersect. All right, back to now. I'm going to quit and go to find the area of those curves. Let's do the first part. That is the area of R. Math 9 is your friend. And that means we're going to take our limits of integration from -2 up to 0. And then we want y1 minus y2. And y's are found by taking vars, y-vars, function, y1. I don't know of any quicker way to do it than vars, y-vars, function, y2. At the last, you say you integrate in terms of x. Now, if you have a different calculator, I believe you put, it doesn't have that integral symbol. You do the function, the x, and then the limits of integration. So you would do y1 minus y2, comma, x, comma, -2, comma, 0. Should give you 5.483. Right on this screen, I'm going to do the other region that we called it region S, and that's going to be y2 minus y1 with different limits of integration. Math 9 is what you need, and now it's from 0 to 1.828. And that's going to be y2 minus y1. Function vars, function, y2 minus vars, y-vars, function, y1. If you get into a pinch and you can't remember, oh, which one is the top and bottom? If you get a negative area, it really is just the absolute value of the answer there. All right, let's see. We should get 3.59 when we add it to those two together, 5.48 and 3.59. We should get, and I'll take us back here, that was 5.48 and 3.5949. Add those, 9.078. All right, thanks for watching. Oh, we